Today we are going to focus on EMF graphs. This is the paper that we are going to focus on. The first graph that we are going to deal with, and then decide its V external. And then when we go down, we find a current, as you can see there. This is a straight line graph. So every straight line graph falls under the equation y equals to mx plus c. That's where each and every straight line graph falls. So another thing that you have to know about this graph is that all these EMF graphs are derived from the EMF equation, which is E equals to I R plus R. Those are the equation in which all these graphs are derived. So now we have to reconcile. We have to reconcile this graph with this graph. So what do we know here? We know that current, or our I here, is the x variable, is equals to the current. What do we know from this graph? We know that our V external, or our V, is our what? Is our y axis. So we have to reconcile an equation in the form of y equals to mx plus c. So we are going through this content, and then after we are going to apply this theory to the what? To the questions. So now let's reconcile. What is needed here? We still need this. This is needed in the equation because it's what is our x variable, and also we also need a V external. We don't have a V external, but we know that a V external is made of what? V external equals to I plus R external. So that's how our V external, we find it. So now when we come to here, we just let this and say IR plus I. So we just like multiplied. We just multiplied and removed the brackets. So what do we know that this is equals to? This, as we did here, this is equals to the what? This is equals to the V external. So this is equals to the V external. That's why we are allowed to come here and say V external, which is our y. So this is our V external plus what? Plus IR. And then we come here, our EMF. So we need our equation in the form of y equals to mx plus c. And then it means that we are going to rearrange the equation. We're rearranging the equation, and then we are going to keep this one that side. So it's going to be EMF minus IR. So now this is our x now. This is our x. So we want our x to be directly at this position now. This is on our y. We have done well with our v. And then now we are going to say negative r. This is in the position of x now. It's still our current there, plus EMF. So